Alright, this video is about complex fractions. And complex fractions sounds difficult, but it's really just a fraction divided by a fraction. So let's just do an example. Let's say we have 1/2 divided by 2/3. And that's a complex fraction because you have a fraction on the top and a numerator, and then a fraction in the denominator. And what you do to solve a complex fraction is you multiply by the reciprocal of the denominator. The reciprocal of any fraction is its inverse. Like 3/5, the reciprocal would be 5/3. You just flip it over, okay? So when we flip over 2/3 on the bottom, in the denominator, we're going to get 3/2. And the reason why we're doing that is because we want to eliminate. The 3's will cancel and the 2's will cancel, and the denominator will come to 1, which is exactly what we want. But if we multiply the denominator by 3/2, we must multiply the top by 3/2. And then we multiply straight across, just like you normally would with fractions. 2 times 2 is 4, and 1 times 3 is 3. And that is our answer. So 1/2 divided by 2/3 is 3/4. So let's talk about what we did, and we're going to write down some steps. Alright, you're probably wondering, why do we need to multiply the denominator by its reciprocal? And here's the truth. Nobody can divide by a fraction or decimal. Nobody can. Not Albert Einstein, not Steve Jobs, nobody. Everybody has to do the same work. So I'll show you, okay? So let's take 2 and let's divide it by 4/10. So we'll do it as a decimal once, okay? And then we'll do it again as a fraction. The first thing that you have to do is hop this decimal, okay? And then we hop it here and we make it 20. And then after that it comes straight up and our decimal is in our answer there. And 4 goes into 25 times. And maybe you've never thought about it, but the reason you have to hop that decimal is because you're not allowed to divide by decimals. Nobody's allowed to divide by decimals. It's not possible. And so the whole purpose of hopping the decimal is to get this to a whole number. When you hop that decimal, now you're dividing by 4. Just 4. Not 4/10, not 0.4, just 4. And that's why you had to hop the decimal. And you only have to hop the decimal when the divisor is a decimal. Maybe you've never thought about it before, but that is why you do it. Let's do that same problem, but now let's do it as a fraction. So the original problem, let's write it again, was, don't forget the answer was 5, okay? I'll put it up here. The answer was 5. The original problem was 2 divided by 4/10. So we're going to do 2 over 1 divided by 4 over 10. And these two are the same problem, okay? This says 2 divided by 4/10, and this says 2 divided by 4/10. And the first thing that we have to do is get rid of the fraction in the denominator, because just like over here, we can't divide by a fraction. We can't divide by a decimal or a fraction. Nobody can. Our entire goal is to get it to where there's a 1 on the bottom. Again, a whole number. Because we're trying to divide by a whole number. We can only divide by whole numbers. And then, when we do the work, we get 20 divided by 4, which again is 5. We get 5 no matter what, because that is the answer. And if you do it as a fraction, or if you do it as a decimal, you still have the exact same work. You're still doing whatever it takes to divide by a whole number. Alright, let's try some of these for practice. Okay, so let's just do number 1. And it says 1/3 divided by 5. But 5 is a whole number. Notice it's a whole number, so we got to put it over 1. Because we need 2 fractions. We need a fraction in the numerator, and we need a fraction in the denominator. When we flip over the denominator and multiply by its reciprocal, it's going to turn into 1/5. And whatever we multiply, notice they're both the same number. Like I can't change that. Like if I'm multiplying the denominator by 1/5, I've got to multiply the numerator by 1/5. I can't change it. And of course what happens is that the 5's cancel and the 1's cancel, and the bottom just pretty much goes away. Okay, it goes to 1 really, but you know, a denominator of 1 doesn't really mean much. And then the top you just multiply straight across. 1 times 1 is 1, and 3 times 5 is 15. So the answer is 1/15. Alright, to do the next one, we need to review something. So right now, as it reads, it says 2/3 divided by 2 and 1/3. Well, we can't leave it like that, because we need two fractions, not mixed numbers. We need to have like a fraction on the top divided by a fraction on the bottom. Can't be anything else. It has to look like that every time. And the way that this one is written is just, we can't have it. So if you forget how to change improper numbers into mixed numbers, mixed numbers into improper, and vice versa, I'll show you both, but let me show you. Okay, one thing that you should always remember is that the bottom number is never going to change. It was 2 and 1/3, it will stay 3. That will never change, okay? So whatever it is there, it'll be here. But the top number will change. The numerator will be something different. And what you're going to do is you take 2 times 3, which is 6, and then you add 1. So you go all the way around, and so 2 times 3 is 6, plus 1 is 7. And that's our new fraction, 7/3. And now we can continue, because now it's in good form. So go ahead and try to do it yourself first. Think about what you're going to do, and you're always going to do the same thing. You're always going to take the bottom number, I'm going to extend my line here, and you're just going to flip it over. So 3 will now be on top, and 7 will now be on the bottom. And then you're just going to write that same thing above, and then you're just going to multiply straight across. These 7's cancel, these 3's cancel, and then you multiply. Something happens up here too. These 3's also cancel. Anything that's on the top and on the bottom will cancel each other out. So now I have 2 times 1, which is 2, and 1 times 7, which is 7. I want to show you something else too. It might help you in the future. So I rewrote the problem again, and I'm going to write it again one more time, but this time I'm going to write it horizontally. And the only reason I'm doing that is just so we can maybe see it a little better. Notice how the denominator is 3, in both of them. And when that happens, it kind of works out really well. And you can divide straight across when that happens, but only when the denominator is the same. So 3 divided by 3 is 1, and 2 divided by 7 is 2/7. And then you get 2/7 over 1, which is the same answer that we got here. Notice that we got 2/7 over 1. The 1 really doesn't change anything, so we say our answer is 2/7. But again, that only happens when the denominator is the same. I've had students go out of their way to find common denominators just so they could do it like that. And if that makes sense to you, then that's fine, but it's definitely not the easiest way to do it, unless it works its way out automatically, like that one did. Let's try another one. Okay, we have another example that is not in good form right now. This needs to be rewritten because we can't have it in mixed number. Alright, so don't forget, because it's 3 4/7, because it's a 7, it'll stay a 7. So don't worry about changing that. But to find out the new numerator, you're going to take 3 times 7, which is 21, and then add 4. So 21 plus 4 is 25. So we're going to have to rewrite this as 25 over 7. And notice how this also has a common denominator. So we'll do it again when we're done and check ourselves. So we're going to flip over the bottom, and now it'll become 7/5. And these 7s will cancel, these 5s will cancel, and actually we have 7s canceling up here as well. And we also could cross-cancel the 25 and the 5, but let's just keep it simple, and we haven't got to that yet. We're going to learn cross-canceling here shortly. So 25 times 1 is 25, and 5 times 1 is 5. And 25 divided by 5 is 5. And so our answer is 5. Alright, I rewrote the problem again, and notice that they did have a common denominator of 7. And so 7 divided by 7 is 1, and 25 divided by 5 is 5. And that is exactly what we got. We did get 5, and we could have done it either way. Okay, I want you to try number 10 by yourself, and then check and see if you got it right. Alright, number 10 says 7/8 divided by 1 1/6, but you needed to rewrite it as 7/8 divided by 7/6. So make sure you made it that far. And the reason I got 7/6 is because 6 stays the same, and then 6 times 1 is 6 plus 1 is 7. If you have any questions, please raise your hand and ask for help. Then we're going to flip over the bottom, multiply by the reciprocal. These 6's cancel, these 7's cancel. Anytime that you have the same thing on the numerator as you do in the denominator, they cancel each other out. And it happens again up here. My 7's cancel, and I get 6/8. But 6/8 can reduce. Anytime that both of the numbers are even, 6 is even and 8 is even, anytime that happens, you know it can be reduced. And the easiest way to reduce fractions that are even is to take half of each. Half of 6 is 3, and half of 8 is 4. I know I'm done because 3/4 cannot be reduced because 3 and 4 are side by side on a number line. For example, 1/2, 2/3, 3/4, 5/6, 6/7, 7/8, and so forth. None of those can be reduced because they're side by side on a number line. Notice how it goes like 1, 2, 2, 3, 3, 4, and so forth. They wouldn't have any common factors. So if you get down to a number, a fraction, and it's 7/8 or 8/9, or even 22/23, you cannot reduce that anymore. So you know you're done. Okay, I want you to try number 13 by yourself. You have to change both of these. So make sure that you're changing both fractions before you start dividing. 1 5/8 will become 13/8. And 9 3/4, 9 times 4 is 36, and 36 plus 3 is 39. And then again, the 4 doesn't change, and neither does the 8. So this should be the problem that you started with. If you did not start with that, then go ahead and try again. Alright, so we should be flipping over the bottom, and now it'll be 8/13. The 8's will cancel, the 13's will cancel, and we do have some cancellation that's going to happen in the top fractions. So let's go over that. When you cross-cancel, what you're really doing is you're reducing the fraction before you get to the end, before you start multiplying. And the purpose of it is that you're trying to get smaller numbers and make your math easier, because don't forget, the best mathematicians are lazy. So the first thing that I see is 4 and 8 are even, so we can at least take half of both of them. So half of 4 is 2, and half of 8 is 4. But if I look again, they're still even. I can go again. So half of 2 is 1, and half of 4 is 2. So now my numbers, the numbers that I'm actually going to use in this problem are the 2 and the 1. Now I know you're not going to erase yours, but just know that we're not using the 8 and the 4 anymore. We're using 1 and 2. And I don't know how good you are at your multiplication facts, but there actually is 3 13s in 39. So you always ask yourselves, can 13 go into 39? And the answer is yes. Then you say, okay, well, how many times can it go? And 13 goes into 13 once, and 13 goes into 39 3 times. And so now we're not using 13 or 39 anymore. Now we're using 3 and 1. And look how easy, look how much smaller these numbers are. Which is why people do that. You know, they want to do cross-canceling because it makes their life so much easier. And then the answer becomes 6, because 6 over 1 is just 6. Anything over 1 is itself. I always think about it as cookies over people. So if you have 6 cookies and 1 person, that person still gets all 6 cookies. Alright, so try 16 by yourself, and then play the video. Both of these fractions needed to be changed. You cannot divide mixed numbers. Nobody can. They needed to be changed into improper fractions. So to change a mixed number into improper fraction, the 5s will not change. So you should have had 5s as your denominators. And then 2 times 5 is 10, plus 3 is 13. And then 5 times 10 is 50, plus 2 is 52. So your new fraction is 52 over 5 divided by 13 over 5. And then we're going to flip over the denominator. Oops. That's a really common mistake. Be careful. Make sure you're multiplying by the same thing, that you don't flip it again, just like I did. Okay, so the 13s will cancel, the 5s will cancel, and in fact these 5s up here will cancel as well. And then we'll get 52, I'm going to write it down here, I'm right here, 52 over 13. If you play cards, this is going to be very obvious to you because there are 52 cards in a deck, and there are 4 suits. So each suit has 13 cards. So 52 divided by 13 is 4. There are 13 spades, 13 hearts, 13 clubs, and 13 diamonds in a deck of cards. So the answer to number 16 is 4. Alright, we're going to do one more, number 19. Okay, so we have 16 and 2/3 divided by 6 and 1/4. Both of these need changed. And again, the 3 will not change and the 4 will not change, but we will have new numerators. So 6 times 4 is 24, plus 1 is 25. Then we got 3 times 16 is 48, plus 2 is 50. So that's our new problem. Then I'm going to flip. 25s cancel, 4s cancel. And I'm going to rewrite this on another page because we're going to have some cross-canceling here. Okay, so looking at the 3 and the 4, they don't have anything in common. They're side by side on a number line. They're not going to reduce at all. But looking at the 50 and the 25, think about it as quarters. You know, 25 cents is 1 quarter, 50 cents is 2 quarters. So I could divide each of them by 25. So if I do, there's 1 25 and 25, and there's 2 25s and 50. So now our new numbers that we're dealing with are 2 and 1. And it's so much easier. We don't have to work as hard at all. And then we multiply straight across. 2 times 4 is 8, and 3 times 1 is 3. Now this is the first time that we've had an answer that wasn't a whole number. So I'm glad this has happened, because we can't leave it like that. 8/3 at this time in our math career isn't in best form. As you get older, it's actually more accepted, but right now it's not. So we have to change it. So to change an improper fraction into a mixed number, let me show you how you do it. What you do is you take 8 and divide it by 3. So how many 3's go into 8? Well, 2, right? Because that would be 6. And how close did we get? You know, if we got to 6, but we wanted to get to 8, we were 2 away. So our remainder is 2. And the 3 never changes. So our answer is 2 2/3. So let's do it again a different way. So 3 and 8. 3 goes into 8 twice, and then there's a remainder of 2. So the remainder becomes the fraction here. So I have 2 over 3. And then your answer becomes your whole number. Still the same thing, 2 2/3, 2 2/3. So either way you can, I mean, some people do it in their head, other people write it out in long division, it doesn't matter. Others use their multiplication chart, but you do need to change it into a mixed number.